In this video, we're going to go through numerical problems under logarithm. Now here is the first question. If log to the base a of q is equal to 5 plus log to the base a of a b, and if you have c to be equal to a to the fourth, and prove that q is equal to a, b, c. So the first thing we need to do is to rewrite it. So that will be log to the base a of a q, and here we're going to have 5 plus log to the base a of a p. So I'm just going to take this to the other side. We're going to have log to the base a of a q minus log to the base a of a b, and that is equal to a 5. Now we can express this as a single logarithm from the laws of logarithm. This is going to be q divided by b. This is equal to 5. This is a logarithmic equation. I'm going to change it to an initial. So I need to take the a and power it to the power of a 5. So that will be a to the 5th power, and this will be equal to q divided by b. So we have q divided by b, and that is equal to a to the 5th. Next up, I'm going to cross multiply with this b. And so I'm going to have q be equal to b multiplied by a to the 5th. Now we can split this because we already have that c is designated a to the 4th. So I'm going to say q is equal to a multiplied by b multiplied by a to the 4th. Because if I take this, multiplied it by this, that is going to give me a to the 4th, or a to the 5th. And since we know this is the same thing as a c, we're going to change it. And so q will be equal to a multiplied by b multiplied by c. That is going to be the answer. That is how to solve it. Now here is the second question. Show that a to the log to the base a of x is equal to x. And this, you need to show that a to the power of log to the base a to the power of m of x is equal to x to the power of 1 divided by m. So let us start with this one. Now, for this, I'm going to say let b be equal to a to the log to base a of an x. Now I'm going to take log to the base a of both sides. So that will be log to the base a of a b. And here we're going to have log to the base a of an a to the power of log to the base a of an x. So from the laws of logarithm, I'm going to use the power rule to take this part to the front. So that would give me log to the base a of a b. That will be equal to log to the base a of an x multiplied by log to the base a of an a. Now obviously this is going to give me a 1. So I'm just going to have log to the base a of a b, and that will be equal to log to the base a of an x. Now notice that we have a log to the base a of basically log to the base a on the right hand side as well as on the left. So from here we can actually cancel these stuff out. And if we did that, we're going to have that b will be equal to an x. Now remember what b is. We said b is equal to this stuff. So I need to rewrite it. So this is what you're going to have, because we know that this is equal to this. And so that is basically it. That is how to do it. Now if you know how to do this one, you can well try this by yourself. So feel free to pause the video and try working it by yourself. Now I'm just going to say a, or a y rather, let it be equal to a to the power of a log to the base a of m of x. Now from here, I know that this is going to be the same thing as a to the 1 divided by m of log of a to the x. We have already worked this. Now if you have not gone through the video which I made on the laws of logarithm, I would actually recommend that for you. That would help you to understand why all these manipulations and transformations actually take place. The link to the video has been dropped in the description section below. Now from the laws of logarithm, we can take 1 over m and take it to this other side as a power of the subject. So this will be equal to a to the log to the base a of x to the power of 1 over m. So gradually from here, you can see that we're gradually coming closer to this expression which is required of us. So from here, you can just work it as you know the original stuff. So I know that y is equal to this whole stuff. So what I'm going to do is take log to the base a to both sides. So this is going to be log to the base a over y, and on this side we're going to have a to the power of a log to the base a of x to the power of 1 divided by m. Well, I didn't take the logarithm of this side. So that is log to the a, and here we're going to have a of a to the power of a log to the base of x to the power of 1 divided by m. So obviously this stuff is going to go to the front, and we're going to have a log to the base a over y, and here we're going to have a log to the base a of x to the 1 over m, and that will be multiplied by log to the base a of an a. Now obviously we know this stuff is going to get cancelled, or originally it's just going to change to a 1, so we don't really need to worry about this part. So that would help us to form this stuff, that is log to the base a over y, and that will be equal to log to the base a of x to the power of 1 over m. Now obviously these are going to get cancelled, and then you're going to have y is equal to x to the 1 over m. Now we already know what y was set to be. We designated y as this stuff, so we're just going to change the y to the original form of it. So this is going to be a to the power of log to the base of a of an m of x, and all these obviously is equal to 1 over m. Now this is actually the extrapolation. So this is basically how to work the derivation of the second one. Now here is the next question. If log to the base 10 over 2. Now you need to know that if you are not actually given a visible base of that logarithm, then that basically means that is the common log. That is log to the base 10. So you got log 2. Log 2 is equal to 0.3010, and log 3 is equal to 0.4771. So if we have these parameters, we are required to find out what is going to be the value of log 5 of this stuff and this stuff. So let us start with number 1. We need to find log 5. So what we're going to do is this. We know that 5 is the same thing as 10 divided by 2. Now we need to work this without use of calculators. And even if you did have a calculator, you might well work it just to find out, but there would well be exams where you will not actually have access to the calculator, so you better get learning this without the method of calculators. So that is basically how we're going to do it. Now we need to see how we can bring this stuff into perspective. Bring it into 5. So you need to work some mathematical transformations. We know that 5 is the same thing as 10 divided by 2. And I could well work this because we have a 2. And there will be some forms in which later on we're going to see that log 2 will be formed. So that is particularly what I'm going to do. I'm going to have log of 5. That is going to be log of 10 divided by 2. Now from the rules of logarithm, we should have this as log 10 minus log over 2. Now we know log 10 is a 1 because that will be log to the base 10. Like I told you, if you do not really have no number written there, then that is basically a 10. So this is log to base 10 over 10. That obviously should give us a 1. So you got a 1 there, and here we have log 2. Now what is log 2? That is 0.3010. So we need to find what that is going to be. So that gives us a 0.699. We're going to have a 0.699. This will be the answer to this question. Now let us go on to the next one. So the next one we have a log 0.3 all divided by 3. Now I could express this in this form. This is 1 over 3 multiplied by log to the base 10 of 0.3. Now we know that 0.3 is the same thing as 3 divided by 10. So this is going to be a third multiplied by log of 3 divided by 10. So this will be log to the base 10 over 3 minus log to the base 10 over 10. Now obviously this is going to be a 1, and this, we have been given log of 3 as a 0.4771. So that is a third multiplied by 0.4771 minus log 10, which is a 1. So we need to find out what that is going to give. So this is going to be 1 over 3 so that gives us a 0.522, a negative rather, negative 0.5. So I need to wipe these out. Now I need to take a third of that. So that gives us a negative 0.1743. This will be the answer to this question. Now let us go into the last one. So here we have a log to the base 10 of this stuff, that is 2 to the negative 1 plus 3 to the negative 1. Now this stuff, you could well change it to its fractional form. So this is going to be 1/2 plus 1/3. Well, now I need to work this. We know that this is going to have a GCF. Well, that will be an LCM rather. What is the lowest common multiple of 2 and 3? That will be a 6. So we have a 2 divided into a 6. That is going to give us a 3. So you got 3 multiplied by a 1, and that gives you a 3. And here we're going to have a 3 into the 6. That gives you a 2. So that will be 2 multiplied by 1, and that gives you a 2. So we should have a log to the base 10 of 5 over 6. Now from here we know that this is going to be log 5 minus log 6 basically. This, we do not really know what log 5 is. We were not given that. But we could work it in another way, just as we did it for the first question. So here what I'm going to do is this. I'm going to make it to be log 10 divided by 2. And on this side I'm going to have log of 2 multiplied by 3. And the fourth question says, without the use of tables, find the value of this stuff. So you can find that we have similar bases here. We have a log to the base 2 for each logarithm. So we could combine all this. And since we have a plus and a negative there, that is going to be a multiplication of this stuff and this. And that will completely be divided by this. So that is going to be log to the base 2 of 5/3 multiplied by 8 over 7. And this is going to be minus log to the base 2 of 5 divided by 28. Now we know that from here we cannot really work any cancellations. So we just need to go right ahead and have it as a 40 divided by 21 at least. Now if we have it minus log to the base 2 of 5 divided by 28, I think I need to rewrite that. We're going to have a log to the base 2 to be 40 divided by 21. And this will be divided by 5 over 28. And so this could be changed So log to the base 2 of, well, that will be 40 divided by 21. Now we will change this to multiplication. So this should be 28 divided by 5. Now we know that 5 can cancel into a 40. That is going to give us an 8. And here we're going to have a 7 cancel into this. That is going to give us a 3. And if you have 7 cancel into this, that is going to give us a 4. So this is going to be log to the base 2 of 8 over 3, and that is multiplied by 4. So here now we have a log to the base 2 of a 4 multiplied by, that is 8 multiplied by 4, that is basically a 32. That is divided by 3. So here now we're going to have this. We're going to have log to the base 2 of a 32 minus log to the base 2 of a 3. Now in this case, we have this stuff. This is going to be log to the base 2 of a 2 to the 5th. And then we're going to have this of a 3rd. So I need to rewrite that. So here now we're going to have 5 come to the front. And we'll have 2, 2 there. And this will be log 2 of a 3rd. Now here is a 5th question. We need to prove that these are correct. So let us start with the first one. Now we have that log to the base q of a p multiplied by log to the base r of a q multiplied by log to the base p of an r is equal to 1. Now what we're going to do is use a method of the change of bases. So for this one, I'm going to say that we're going to have log to the base c of a p. This will obviously be divided by log to the base c of a q. I will still use that for this other one. So this should be multiplied by log to the base c of a q divided by log to the base c of an r in this case. And here we're also going to have log to the base c of an r divided by log to the base c of a p. Now here we can see that log to the base c of a q, this can cancel out, and log to the base c of an r can cancel. We can also have these cancelled. So everything changes to a 1. So that is basically how it works. Now let us go on. We need to find that this is equal to this. So this is the right hand side. And this is whoa, I made a huge mistake. This should be called the left hand side. And this is going to be called the right hand side. So we basically need to show that the left hand side is equal to the right hand side. Now for the left hand side, we have log to the base a of an n multiplied by log to the base b of an m. So this, we're going to work it with the change of base. Let us use a new base c. So we're going to have this of an a. Now we're going to work that with this also. So that will be log to the base c of an m. This will be divided by log to the base c of a b. Now, going over to the right hand side. So the right hand side is log to the base b of an n. And that is multiplied by log to the base a of an m. So here we're still going to work the change of base. So this will be, and we're going to use c. So that will be log to the base c of an n. And here we have log to the base c of a b. This is multiplied by log to the base c of an m. This will be divided by log to the base c of an a. Now we can find that this side is actually the same as the other side. As you can see, we have this stuff on top as well as on this side. Now for this, we have this here, and then we also have this. And because we know that multiplication is commutative for scalars, that is non-vectors, so we should have this be able to switch to this place while this goes over to this. And if we did that, you're going to see the same expression as what you have here. So basically that is correct. We have that this is actually equal because we have this be equal to this other. So this is how to do it. This is completely correct. Now here is the next question. If log to the base 8 of an h is equal to a half k and log to the base 2 of a 2h is equal to m and m minus k is equal to 4, and we should find an h. So the first thing we're going to do is work this. So let us start. Now notice that we have an 8, which is actually different from a 2, but we could actually express an 8 in terms of a 2 because we know that this is actually a power multiple of a 2. So that is going to be 2 to the third. And so we have an h here. And a half k, that is k divided by 2. Now we can take this and multiply it to this other side. So we're going to have a 2 log to the base 2 of a third. And that is going to be a h, and that will be equal to a k. Now of course this is actually going to come here as we made it from the rules of logarithm. So this should be a denominator, and that will be a 2 there, and this is going to be a k. Now this stuff is going to go up here and become the power of it. So we're going to have a log to the base 2 of h to the power of a 2/3, and then on the other side we're going to have it as our k. So we got the k. Now the m is log to the base 2 of a 2h, and that is equal to an m. So we need to find m minus k. So m minus k is going to be this minus this. So that will be log to the base 2 of a 2h minus log to the base 2 of a h to the 2/3. Now since we have the bases to be equal or similar, we're going to work it like this. So this will be 2h divided by h to the 2/3. So I think I'm going to wipe these out and take these out also. Now we know that this is going to change to this. This will be m minus k, and this is going to be equal to log to the base 2 of a 2h. Now we know this is a 1. So we have h to the 1 divided by h to the 2/3. So that should be a 1 minus 2/3. So here now, if we have 1 minus 2/3, this is the same thing as 3 divided by 3. So if we have 3 minus a 2, that should leave us with a 1/3. So that will be m minus k, and that will be equal to log to the base 2 of a 2h to the 1/3. Now, we already know that m minus k was told us to be equal to 4. So I need to change this to a 4. This is going to be a 4. And here we're going to have a log to the base 2 of a 2h to the third. Now, I'm going to change this from its logarithmic expression into an indicial. And we're going to have 2 to the 4th. And that will be equal to 2h to the 1/3. Now, this is 2 to the 4th. This is 2 to the first power. So we can have it as a 2 to the 4th divided by 2. Basically, what I did is divide both sides by 2. So this is going to change to 2 to the 3rd. And this will be equal to h to the 1/3. Now, from here, we need to take this stuff away. How can we do that? In order to take this away, we need to take the power of a third to both sides. So here we're going to have a 2 to the 3rd. And this is to the 3rd. Here we're going to have h to the 1/3. This is to the 3rd power. And this is going to cancel out. And so you would have a 2. Well, that is a mistake on my part. This should not cancel. This should give us 2 to the 9. And here we're going to have this cancel out. So that will be h. Now we know that this is going to be the same thing as 2 to the 6th multiplied by 2 to the 3rd. 2 to the 6th is actually going to give us 64. And so this is 64 multiplied by this, which is going to be an 8. So the answer should be 64 multiplied by 8. So that is 512. 512. So this is the answer to the question. Now here is the 7th question. Find x if log to the base 10 of x minus log to the base 10 of 3 is equal to 1. So that is going to be log x minus log 3 is equal to 1. Now on this other side, we know that this stuff is going to come together. So that will be x divided by 3. This will be equal to a 1. We know this should be a 10. So obviously this is going to change into a 10 raised to the power of a 1. And this will be equal to x divided by 3. So we got x divided by 3 is equal to 10 to the power of a 1, which is the same thing as a 10. And so if you wanted to find out what will be the x, you just want to cross multiply with the 3. So that will give us a 30. And so this will be the answer. X is equal to 30. And the next one, you have x is equal to log to the base 6 of 216. Now we know that if we have 6 multiplied by 6, this is going to give us a 36. And if you took 36 and multiplied it by 6, this is going to be 6 multiplied by 6. That will give you 36. So I'm going to place a 6 there, and I will have a 3 here. Now we have 6 multiplied by this. That will give us an 18. And 18 plus a 3, that gives us 21. So this is it. We know that 6 to the 3rd power, that is going to give you 216. So we have x equal to log to the base 6 of 6 to the 3rd. Now this is going to go to the front. So x is going to be 3 multiplied by log to the base 6 of a 6. And this whole stuff changes to a 1. So this will be x is equal to 3. And that will be the answer. X is equal to 3. And the third one is this. Log x minus log 3 is equal to a 1. Now obviously this is almost similar to what we did initially. Well, it is completely. So that is a mistake on my part. So we're just going to move to the very last one. Now for the fourth one, we have log to the square root of 8. That is equal to 4x minus 5. And this is all equal to 3. So this stuff should actually be written this way. This is going to be 8 to the 1/2 minus a 5. And this is equal to a 3. Now this stuff, we can actually take it to this place. Now doing that, that would be reciprocated because the power of the stuff here must always change. But we don't just need to take that there. I want to take this and reduce it from an 8 to a 2. So this is going to be log to the base 2 over 3. So this is log to the base 2 raised to the power of a 3. That will be multiplied by power of a 1/2. And on this side, we're going to have a 4x minus a 5. And here, we're going to have a 3 on the other side. Now, this should give us log to the base 2 of 3/2. And here, we're going to have a 4x minus 5. And this is equal to a 3. Now, from here, this is going to go to this place. but it will be really reciprocated. So this is going to be a 2/3 multiplied by log to the base 2 of this stuff, 4x minus 5, that equal to 3. That was a mistake. So that is what you got. Now from here, I know that this is going to become the power of that subject. So this will give us log to the base 2 of 4x minus 5. This is raised to the power of 2/3. This is equal to 3. Now from here, I can express this stuff in initial form. So that will be 2 to the 3rd. And this will be equal to 4x minus a 5. That is raised to the power of 2/3. Now I know that this is actually an 8. But I really need to take this power away from here. Now what am I going to do? The best thing I need to do on this other side, as well as this other side, is actually to take the power of the reciprocal form of this. So that is going to be 3/2. So I'm going to take the power of 3/2 to both sides. So this will be 2/3. And we're going to have a 3/2 on this side. And here we have a 4x minus a 5. This is going to be 3. Okay. That is 2/3. And so we have a 3/2 here. And obviously this is going to cancel this, and this would cancel this. And so here we're going to have this multiplied by that. That would be a 9. So this would be 2 to the power of a 9 divided by 2. And that is equal to 4x minus a 5. So this will be 2 to the 9th. So what is going to be 2 to the 9th? Sorry, find that. So that gives us 512. So this is going to be 512 to the power of a 1/2. This is equal to 4x minus a 5. Now this stuff, we do not really have a square root of 512. So this should rather be written this way. This is going to be the root of a 512. And this will be equal to 4x minus 5. Now remember, we need to find the x, so we're not yet done with this work. So I'm going to take it to this other side. So 4x is going to be equal to 512 plus a 5. Next up, I'm going to divide through rather by a 4. So this is going to be what we're going to have. You'll have root 512 plus a 5, and this will be divided by a 4. That will be the answer to the question. X is equal to root 512 plus 5 divided by 4. Now we need to move to the very last question for this video. So this is going to be the last question. Find x and y if log of x squared plus y squared is equal to 1 plus log 13. And also log of x plus y minus log x minus y is equal to 3 log 2. Now, as you can see, we do not really have a base, which is physically represented there. So clearly, you know that should be the base of 10. That is common logarithm. So let us bring it up. We have log, so I need to write this. Log to the base 10 of x squared plus a y squared. That is equal to a 1 plus a log to the base 10 multiplied, added rather, to this stuff. Now this stuff is the same thing as a log to the base 10 of 10. So this is what we're going to have. Log to the base 10 of x squared plus y squared is equal to log to the base 10 of a 10. So this is what we're going to have. Now on this side, we can combine this stuff. So that would make us have log to the base 10 of x squared plus y squared. And this will be equal to log to the base 10 of 130. that is going to be 10 multiplied by 13, which should give us log to the base 10 of 130. Now, since we have that, that is going to be log to the base 10 of this stuff. And this will be equal to log. Well, I need to rewrite that. So this is what you have. And you have 130. So obviously this stuff is going to get cancelled. I'm going to wipe these out. So this will be x squared plus y squared is equal to 130. Now we're just going to place it here. That will be the first equation. Now we need to work this other one. So we're just going to work it using the same method and try to see what that is going to give. So we have a log of x plus y minus log of x minus y. And this is equal to 3 log 2. So on this other side, we know that this is basically going to change to a x plus y divided by x minus 1. And on this side, we're basically going to have a log 2 to the third. And basically, this should give us an 8. So from there, we know that this is from the fact that this is a common logarithm. So this should be log to the base 10. Now, if I cancel these out, I'm basically going to have this. And this will be equal to 8. So that is the next one. The other one we have here is x plus y divided by x minus 1. And this is equal to 8. So we need to solve this. How can you solve this? If you were required to solve this, how would you do it? Well, I need to make this a y. So this is going to be y. This should have been a y. So what is going to be the first step? What would I do to solve this? Now the first thing you're going to do, you're just going to take this part and have x minus y get cross multiplied to the 8. And you're going to have something like this. This will be x minus y. And here you're going to have 8 multiplied by x minus y. Excuse me. And then you're going to have x plus a y. And here you're going to have 8x minus a 8y. So I just need to take it to this other side. So I'm just going to take this to the other side. So this would leave us with this. And we're going to have a 8x minus an x minus an 8y minus a y. So 0 is going to be equal to 7x minus 9y. That is what you got. So I'm going to take these out. Now here we have that 7x minus 9y is equal to 0. So I'm going to take this to the other side. So 7x is going to be equal to 9y. And x is going to be equal to 9 over, well, 9y divided by 7. So this stuff, I'm going to take it and plug it as x from the first equation. So I'm just going to wipe this one out. Now, if I did that, we know that is going to be 9y over 7 to the power of 2 plus a y squared. This will be equal to 130. So this is obviously going to give us an 81 y squared divided by a 49. And this will be plus a y squared. This is going to be 130. So I need to take this out now. Okay. Now this is divided by 1. So I just need to find out what is going to be the LCM. So this is going to be 49. And 49 into 49, that is going to give us a 1. And 1 multiplied by this, that is going to give us an 81. So that will be 81y squared. And this is going to give us a 49y squared. And on this other side, we're going to have it 130. Next up, I'm going to take this and multiply it with 130. And so you're going to have 81 plus 49. Now 81 plus 49 is basically 130. So you're going to have 130 y squared. And on this side, we have 49 multiplied by 130. So we're going to cancel these out. And so that basically would leave us with y squared equal to 49. So here, obviously, you know that is going to be equal to 7. Now we're basically going to use this equation to find out what x is going to be. We know that from there, 7x is going to be equal to 9y. So we have 7 multiplied by x will be equal to 9 multiplied by 7. And so this is actually going to give us a 63. So we're going to have x is equal to 63 divided by 7. 63 divided by 7 is a 9. So what we find here is that first, x is equal to a 9. And secondly, we have y, that is equal to a 7. And so that basically will be the answer to the question. So hopefully by now, you're actually so good in logarithms that you wouldn't actually have no problems no more in the course. Do have a nice day.